So we're here for PowerShell threat hunting recipes. Just a quick bit about myself. My name's Nathan Dolan. I've been working as a security specialist with Vicura for the last about 3.5 years at this point. In my day-to-day job, I generally work mainly on network security and focusing on firewalls, as you can see by a good chunk of my certifications here. Most of the threat hunting and PowerShell that I get to do is more or less what I'm able to learn and cobble together in when that mythical unicorn of free time pops up randomly. So part of that always learning side of our jobs here. So I've been, like I said, I've been working for 3.5 years after I graduated from SAIT with a computer studies diploma. And before that, I was working as a professional chef for many, many years with a diploma in that from SAIT as well. So on our menu today, just as a quick appetizer, we're just going to do a quick run through of what threat hunting is. I'm sorry, but it kind of has to happen in every talk that's like this. And then also a little bit of why I'm wanting to, why I was focusing on PowerShell for this presentation. After that, the reason that I'm hoping everyone is here is the main course of the demos. This being my first talk, I decided to take the coward's route and just have screenshots from the demo, from the lab environment that I used, which is a full Active Directory environment. But that also means that we can go a bit faster and get a few more examples in here. Time willing, if I can control my rambling, we'll have some questions at the end. And then also, just because there was more stuff than I was able to fit into our time slot, just as a quick takeaway at the end, we have some a couple more examples that we can that I just want to show you guys. And at the end, I'm going to just kind of flip through them so the YouTube recording can see the slides. And if you guys want the slides for your own use, you can reach out to me. The email, my email is on the first page here. So jumping right into it, threat hunting. For me, threat hunting is when you're actively searching through your network or your environment with the assumption that something has gone wrong, security has failed somewhere, and we need to narrow the mean time to detection in our environment. The general thought being, well, usually we can catch, like, we find too many people find out about a breach or an attack after it's too late, after malware has already been deployed on the network, they've been ransomwared, they're being extorted. However, whatever happened that we don't want to see for our clients or for our own environments here. The goal of threat hunting is to try and find the attacker that we assume is going to be there. We assume that our processes have failed somewhere, and try and catch them as early in the attack process as possible so that we can minimize any damage that they are causing to us in our network. And for me, kind of attached to the end of that is also that we want to find a way to automize this. So when we're doing a threat hunt where we come up with a hypothesis and we go to look at and we go to try to prove or disprove that, yes, this is how someone is attacking us. And if we find that, yes, we found this particular vulnerability has been breached, then good, we've met that goal of finding the attacker earlier in the process, we can stop that and we can remediate it. If we are going through a hunt and we find that, and we don't find an attacker, then by automating the process that we just went through and we just developed and theorized, by automating it, we can say, okay, well, now I don't have to manually go through this process every week or every month or whatever interval we're wanting to talk about. Now we can just leave it go, let it go. And then if anything does happen, if that status quo changes, then we can set it up so that it will alert us and we can know and act on that information right away. Why did I want to use PowerShell for this? PowerShell, one of the main reasons is it has very powerful scripting abilities and it is object-based. In some of the demos that I have a bit later on, we're going to start scratching the surface of what the object-based nature of PowerShell will allow us to do. But once again, this is my own fumblings and learning this for myself that I'm wanting to share with you all. There's still a lot more that all of us need to learn, and so that we can get even more value out of it. One of the other reasons is also just the large market share for it. While PowerShell started out just on Windows and Windows servers, you can now install it on Linux and Mac OS as well. So we're able to access and utilize PowerShell through more and more of our environments. Required mention, Deep Blue CLI. Deep Blue CLI is essentially a PowerShell framework made by people much smarter and much more experienced with the platform than I am. You can do a lot of very powerful things with it, only some of which I have listed on this slide. The reason that I'm not going to go too in depth about Deep Blue CLI, this is going to be the only slide that you see about it, is mainly that there's a whole bunch of other videos that will go much more in depth about it. And also my goal for this was, my goal for the end of this talk is so that you guys can take it into your, take what you see here into your environments right away with a minimum of pre-configuration necessary. There will be some that we'll be touching on, but Deep Blue CLI itself requires a sysmon from the systemternal suite to be deployed throughout your environment and properly tuned for your environment. It requires you to already have some of your Windows logging, that is some of the Windows logging IDs that are disabled by default enabled and having already collected logs so that we can properly utilize Deep Blue CLI, where I want the focus to be something that you can take back and use right away on tomorrow or on Monday. So for the demos, we're going to go over a bit of the housekeeping, just some of the things that are required, some of the few things that are required in order to use this, or any of the code that we have below. And then we're going to go through a couple of example threat hunts. So we're going to be looking for file hashes. We're going to look for members of admin groups on endpoint workstations, and then we're going to deploy and use autoruns also from the sysinternal suite. One thing to note with the demos below, since this was in a lab environment, the prompts that I'm using have a bit more privilege than you would most likely be using in your own environments. I do want to highlight that likely if this code doesn't work for you, it's because you need to add in credentials. And I have the process for that in the takeout boxes at the end of the presentation that I'm going to show on the screen quickly. We just don't have time to cover that in what we have today. And once again, just going over the scope, it's something that I wanted all of these demos to be require as little pre-configuration as possible, and also something that someone who doesn't know PowerShell can kind of take what we have here, and I'm hopefully building this up in a clear enough manner that a complete newbie can come in and do what they need to do. One other note, like I said as well, since this is just, I still have a lot of PowerShell learning to do myself, so the code here is something that you can use very targetedly, in a targeted manner. But I'm not quite at the level where I've introduced parallel processing or background jobs yet. So in my opinion, there's a lot of value in the code here that I'll be sharing with you all, but there is still a lot of efficiency that we can also still bring into it further down the road as we develop it further. So jumping into everything, in order to use some of the later techniques to generate dynamic lists that we are going to use to target and access multiple computers, we are going to need to install a PowerShell Active Directory module. If you're on a Windows 10 workstation, this is already built into the Windows October 2018 update. You just need to enable it in the optional features, and I'll show you how to do that below. If for whatever reason you're still using a Windows 7 box, it's not built in with that OS, and you'll need to install the RSAT tools. So if you're already doing Active Directory administration with your Windows 7 box, you should already have the Active Directory module installed for PowerShell. So for activating it in Windows 10, just do a search for Manage Optional Features. Once you're in there, you're going to select Add a Feature. And forgive me, this is going to be a mouthful. You're going to install the RSAT Active Directory Domain Services and Lightweight Directory Services tools. And it's a quick install, it's only 5 megabytes, and then you should be good to go when you start using the Active Directory commands that you're going to see in the next few slides here. You're going to, it's just going to load it into your PowerShell session right away. The next piece here, most if not all of the commands you're going to see in the following demos is going to be heavily utilizing invoke command. Invoke command is essentially the PowerShell on your local device reaching out to another remote device and passing instructions to that PowerShell instance. This is utilizing PowerShell remoting, which is disabled by default. There are many different ways that you can enable PS remoting to enable us to do this work. Deploying it securely would be a talk by itself. So I have some links here of describing how to enable it on specific workstations or how to use GPO and deploy it throughout your environment. And here I have links of how to do both of those securely. And once again, if you need the slides, you can reach out to me and I will get those to you so you have the links more freely available to you. Jumping into some of the more fun stuff, starting our first command here is we're going to find out how to dynamically create a list of different targets that we want to run searches or commands on. In the example that you see on screen, we are first just going to write out manually the target devices that we are looking for. So in this example, we are using invoke command and we are going to the computers that are named Anne and Adam. And then in the script block, you can see in the on the screen there, the code that is inside the curly brackets there, the dir-c, that's the commands that we're actually asking the remote PowerShell instance to send and use. And then it's going to send back the results to us. This is how it will look, and you'll notice this is where we start seeing the object. Start touching on the object-oriented nature of PowerShell. So each of these rows is going to be is considered an object, and each object has multiple properties that we can run different commands on. So for example, we can take some code and say, okay, well, I only want to see files that were created or updated within the last 5 days, or I only want to see files that haven't been written to in the last year. So if it's older than a year, then I only want to see those results. You can start building this out as you go forward and filter it as you want to get the data that you need for whatever you're looking for across your environment. Starting to pull in the Active Directory to create a dynamic list, we're going to use the get AD group member commandlet. This is part of that Active Directory module that we installed earlier. And then we're going to use that to pull down all of the group members of a computer group within Active Directory. And then we are going to select out only the name field, the name property of the returning objects. One thing that you will note is I have the expand switch here, and I'll probably be mentioning this a few times as we're going through the presentation today. But when we're using expand, essentially when the PowerShell is returning all of the objects, name, fields, properties to us, we're going to be emitting the field header. And this will have some impacts when we're using these lists to reach out to different computers. This is how it's going to look. During this command, we're just doing exactly what we say on screen. We're just printing out the target list as it is being returned to us. And you will note once again that there is no header. It's just the list of the computers that are in my demo environment here that we can use right away and feed into some commands, which we are going to do on the next screen. So in this command, instead of listing the computer names individually like we did in my first example, we're using the exact same code to generate that list, and then we're feeding it into the computer name parameter for the invoke command, and then using the exact same command that we've already used. And as you can see here, we're getting results back from a dynamically generated list, and we're being able to see some of the files and the directories that are on the C drives for each of these computers. So most likely you won't see anything on a C drive, but in this particular example, there's already something highly questionable that we found just by looking up what's going on here on Susan's computer. In this next example, we're going to be doing something very similar, except instead of pulling down all of the group members of a specific computer group object in Active Directory, we're going to look specifically for Active Directory computer objects within Active Directory using the get AD computer commandlet. In this particular example, we're just putting in the code, and essentially it's returning all of the computer objects that we see in the domain here. And once again, you're seeing a whole bunch of different properties returning from each object. But for the purposes of running dynamic lists, all we care about is the name field. So in this next example, we're once again selecting out the name field, and you'll note once again we are using the expand switch, which is getting rid of the header. And then one more time, this time we are looking at fields again of just all of the computers, but this time we're wanting to start filtering and being more specific in what we want in our list. So in this particular example, we are looking for any computer objects that start with A. And a potential use case for you guys is if you have multiple sites and different location prefixes. You can be more methodical in, okay, well, if we have an office in Calgary and it starts with CGY, you can do a filter on all of your workstations that start with CGY and do that hunt today and see what the results are. And then the next day, if you have you have a site in Edmonton, you can go and do another filter and then go for the EDM prefix for the Edmonton workstations, or however you have your internal workstations segmented here. And then once again, the exact same code that we were using. We're just going to expand out the names, and we have our target list that we can use. The final piece that we'll be talking about target lists is you can also save this to a CSV or have a CSV created here. Get AD computer, this is the exact same command you were seeing earlier, and we're selecting out the name of the name field, the name property. And then we are taking that output and saving it into a CSV using the export CSV, and just wherever you want to save the CSV as your path. And then we are also putting in no type information so that we aren't saving some of the metadata that might cause us some conflicts when we're importing this in the next few slides. One thing you will note, select object name. This time we are not using the expand switch. So on the next page, when I show you what the output of this is going to be, you'll notice that we do have the name as a header field. And this is just how it looks like in Excel, and similarly, how it looks like when we have it saved to a variable and are printing out what the contents of that variable is. In this particular example, we are creating the variable named computers as delineated in PowerShell with the $ before the variable name, and we are priming it by importing the CSV that we had created in the previous examples. Now we're going to start using a for each loop so that we are able to utilize the target lists that we have created. So we're using a for each, and so that means that we are going to iterate through every object in the list that we are going to feed into this loop. For the computer in computers.name, $computers, that's the variable that we primed just previously. And the .name here is specific for this use case where your CSV list has the header. This is us telling PowerShell that we're wanting to extract the value of each of the rows of the name field. And for each of those values, we are going to prime the computer variable for that iteration of the for each loop. So what this means is, if we're looking at the code, we're once again using an invoke command, and we are going to each computer. So looking at this previous list, it's going to go to DC1, then it's going to go to files, and then it's going to go to Atom, and it's going to run dir C, which is what we've been seeing earlier. And you can see the output as it starts iterating through that in this picture here. Next, we're going to start looking for file hashes. And a use case for this to make this in terms of threat hunting is if we've identified a malicious file or an infected file, and we want to see if any other workstations or users have this in their own devices, on other devices that we might not be aware are compromised yet. So we're going to go through and start building up the different levels of code again until we get to a search throughout our environment for a specific file hash as our final example here. So first, we're going to start off with the commandlet get child item. This is, if you're familiar with Linux, this is very similar to the ls command or the dir command, which those are aliases for the get child item command. But this commandlet has built in that you can reach out to other devices on your network using the syntax here. In this case, if we put this in a command, when we put this in the next in the next slide, when we are targeting a specific computer, we're going to be printing out the C drive of that computer. And the two switches here, file, means that we are only wanting to return the files. We don't really care about the directory names in the context of this search. And then the recurse switch there is also means that we are going to go through each of the subdirectories that is on the C drive looking, and it'll list out the files. So in practice, here we are, we're going to be targeting Atom. The exact same command that we were just discussing, and you can see the files that you can see the file autorun.sc, which you might have noticed earlier was located when we were running the dir command earlier on Atom. And you can also see that we're starting to iterate through the different folders on the Atom C drive, and we're getting the file results that we are looking for. Next, we're going to pull in the get file hash commandlet. And at its most basic, we're just saying, I want a file hash for this specific file. In the example on screen, you're seeing us getting the file hash for the besides CSV, and that is the target list that we created in the previous examples. By default, this will be outputting a SHA-256 algorithm-based hash, but there are a whole bunch of other options that if you need a different or more specific hash of a different algorithm. Next, we're going to pull this together. So using the get child item, we're going to pull out the files that are in the existing folder because we don't have a path any more defined path. PowerShell is going to use get child item and just print out the file contents of the directory that we are running this PowerShell session in. And then we are going to select out the directory name property, the name field, and then we're going to use something here called a calculated expression. And this is something that I specifically wanted to put into one of my presentation demos here, just because this is where we really start scratching the surface of what we can do with the object-orientedness of PowerShell. So essentially what we're going to be doing is we're creating our own property based on other PowerShell commands. So in the next slide here, we're being a bit more, I'm breaking it a bit down since this is one of the more advanced things that I have in the slides. But essentially, we're creating a field or a property with the name of hash, which is the n equals hash. And then we're using the e equals to generate the expression of how are we going to populate the value of this new field. In this example, we are going to be using the get file hash. And then in lieu of using a path, we are using the pipeline variable, which is the $_ And this is going to take every object that is being fed through the pipe to this command. And for every object, we are going to take the full name. So that's the .full name from the pipeline variable. Using that full name, essentially using that full name as the path for the get file hash. You'll remember when we used the get file hash, there were multiple properties as a result of that command. So we are once again segmenting that, and we're saying we only want the hash value. So that's the .hash after the parenthesis get file hash command there. And that means that when we are populating the expression, the value field of the new hash field, we are only wanting the hash output for that command. And this is how it looks like in practice. So we are using the get child item. We're outputting all the files in the directory that I was working in here. You can see the full path. You can see the file names. So you can see the directory name, which we're selecting out. You can see the name of the file, which we are also selecting out here. But you can also see the hash that we are generating for each file here. The next step is pulling this into the for each loop, which we've already covered. And this is going to go and pull out the, start hashing on your target paths and however you define the search here against all computers in your computer list. Finally, on the last piece here, we are now going to do a specific search for a specific hash that we believe or we know is malicious throughout our environment. So going a bit in depth, we're doing a for each loop. So every computer that is in our target list, we're going to go to a specific drive as delineated by the path for get child item. We are going to select out the directory name, the name, and we are going to generate the hash as we did in our previous example. And then we're going to say, pipe all of that output, and we're going to say where the hash, and once again, you'll note that we're using the pipeline variable. So all of the objects created, all of these objects that you see here, we're going to pipe each of those objects in, and we're saying we're looking at the hash property of each of those objects, and then we only want to print out where that hash matches the hash that we have, that we are looking for throughout our environment. One thing to note again, this code isn't optimized. So while I have as this example here that we are searching the remote C drive, this is the remote computer, once again, because we're using PowerShell remoting, we're telling the remote computer to be running these commands. This is telling the remote computer to hash everything on the C drive. If you're doing this in a real life, real fire scenario, you'll want to be a bit more targeted. So for example, we know this piece of malware, they're using the temp folder to try and obfuscate, just to try and hide it away in our file system. So instead of searching for the entire C drive, at least at this juncture until you get more information, you could put in the file path that for every computer, I want to get a hash of all of the temp folder. So just so that it's a bit more optimized, a bit more specific, so you're not, so you can get data in a more live scenario. And hopefully in the future, I can build out this code a bit more so that it can benefit from background jobs or parallel processing. Next, we're going to look at looking up admin user groups on a remote desktop. Now, while most of my work does deal with network security, every once in a while I'm brought into a project or a exercise where we're going over best practices, best security practices with the client and just helping them with their overall security hygiene. And every once in a while the comment comes up, we're trying to do an audit of their administrators, and then the client will just go in and they will pull up Active Directory, pull out the user groups and say, or their administrator user group and say, here are all of our admins. But that's not necessarily true. If I'm an attacker and I've gained admin control of one of your boxes, or another potential use case is I've gained admin access, I've created myself an admin in your Active Directory, I can go into any of your workstations and I can put in a local administrator account. If after that I delete the Active Directory admin that I used to create that account, if you don't have the logging and the monitoring in place to detect that admin account creation, account deletion, you have no idea that something questionable has been going on. Meanwhile, on each of your workstations, the attacker now has a local admin account that lookups in Active Directory won't tell you anything about, but they now have persistence on those machines, on those servers. So in this particular example, we are using the invoke command again, and we're going to a specific computer. And we are using script block. We're telling the remote PowerShell instance to run the get local group member. And we are specifying that we want to see all of the members of the group administrators. And in the output, you see the name, the Susan administrator. So this is the built-in default administrator. That's not too suspicious. And then we have the traders domain users, traders being the Active Directory domain that I have in this lab environment, where they've decided to give all domain users admin credentials on all of their workstations. And I have seen this in production, in actual client productions, and it does make me sad. But once again, going back to the use case I was giving you all, if more people have administrative rights than should have administrative rights, and one of those accounts gets popped, how easy is it then for them to go in and make a local account that you don't necessarily know exists there without something like this, or without another tool that is actively monitoring the creation of all local accounts on a remote workstation. On this next screen here, you'll notice the giant red error. This is because, and I believe this is the third time I've mentioned it and why I've been hinting at it so much, we are running these commands using the remote PowerShell instance. Get local group member was a command that was only introduced in PowerShell version 5. So if one of your remote workstations is running a PowerShell version that is older than version 5, then A, you should patch it whenever you get the cycles to, as soon as you can. And B, well, we still want this data. So in the case that you're acting in an emergency and you're trying to find who has admin access to it, you still can find the information. You just can't use it using a natural PowerShell commandlet if you're on an older version of PowerShell. In this particular example, and I won't go into the lead up so much, since we've covered it quite a bit, we're using write host for PowerShell. That's essentially just a print to your screen. And so we're printing out to the screen just members of the local administrators group on $ using colon computer. The $ using, you haven't seen this before. And that's because, and the reason that we're using that is if we just use the variable $computer, the remote PowerShell instance would look at its own databases, its own variable list, and say, I don't have a computer variable, so this is erroring out. By putting $ using in front of the variable, we are passing through the variable that is on our local machine to the remote PowerShell instance, which means that it's going to use the dynamic nature of that variable, and we don't have to worry about it, and this will print out on our screen nicely. The reason we have this line here is so that if we're iterating through a full list to get a full inventory of your environment, we can see in the output exactly which computers, which devices have which accounts as a member of their administrator. We're using the net local group administrators to actually get us the information that we need here. And then the final line here is just writing host, printing to the screen a new line character, just to give us some white space so that when we are iterating through a list of 100 workstations, that we have a bit of white space just for the readability of the outgoing report. So this is what it'll look like. Once again, members of the local administrators, this is being run on the DC1. The members of the administrators group is administrator, domain admins, and enterprise admins. It's a domain controller. That's not unexpected. That's kind of expected. And once again, this time we're searching for Adam instead of Susan. And once again, we see administrators and domain users. Everyone is allowed full admin access. That's great for everyone. For our final use case here that we'll have time for today, we are going to deploy and use Autoruns. So once again, Autoruns is a part of the sysinternal suite, and what it does is it looks through all of the places where you can configure a program or an application to start automatically when a device is booted. The use case for this is you'll find that many attackers use something that Autoruns can catch in order to maintain persistence on a device, whether it's on startup of this on this workstation or on this server. I want this backdoor to run automatically, or I want this beacon to call back to my command and control server. So first, we're going to have to deploy the Autoruns file to each of the devices that we're going to want to, all the devices that we want to run this on. And we're going to do that using the copy item. And this path here is a shared folder that all of the target devices are able to reach. And just for simplicity, we're saving this onto the C drive for all of the computers in our target list. You can see the output of that below, where it just kind of silently runs in the background. And then if we ran the dir-c again, as you saw in some of the previous examples, you saw this file, because I didn't necessarily do these demos in order. You'll notice that we had the Autoruns deployed to that folder. Next, we're going to need to actually run these commands, or run these files. So we're going once again to each computer in our target list. And we are going to, we are going to run it silently in the background. And you'll notice that instead of printing it to the screen, I'm piping that output, and I'm creating an out file named Autoruns with the computer variable. The end goal being that we want a directory that is full with an Autoruns file that is unique for each of those devices that we are running Autoruns on. So here's how the folder that I was running this in looks. I killed it a bit early, but you can see we have an Autoruns file for the DC1, and we have the Autoruns file for Atom. Now, what can we do with this? Firstly, when we're doing our first run of this, we have a list of, let's say, 50 workstations, and all of them have the same size of an Autoruns file of 736 kilobytes here. Let's say one of those 50 has a larger file. Now, there are a couple different use cases for potential reasons for that. Is maybe an administrator or an engineer needed a specific folder. They went to IT, sorry, not a specific folder. They needed a specific application to do their work. They went to IT, they got this application approved, they have it installed, and then it goes in, and then you have your, sorry, excuse me. Sorry about that. So you go in, you've got your approval, you've installed this application. You can see that you can go in and you can verify, yes, this is authorized. On the other hand, if you see one server or one workstation has a different sized Autoruns file, well, we've gone in and we verified that these workstations should be the same. Is this shadow IT where that engineer installed something that doesn't have IT approval? Or is it that engineer's box got popped and then someone put in a persistence method that Autoruns has caught? This allows us to find that very simply using just these tools. Earlier, when I was talking a bit about threat hunting and how I also think that the end goal of this should all be automation, whether we find something or we don't find something. So, in the example, we've done this report. We have our list of Autoruns for 50 workstations. They're all the exact same. It's beautiful in its symmetry. If we run another script, if we run this script, if we create a script and say, I want to run Autoruns every week, every Sunday, Perfect. And then if we have another script that is monitoring that, if after we've been doing this for 10 weeks and none of these Autoruns files have changed, and all of a sudden Mr. Engineer's file changes and he's once again the only one, automatically it comes back and automatically we go back and we say, well, why did this change? We go through that once again. Was this a change that was authorized? Is this a shadow IT where the engineer just installed something? Or once again, was that workstation caught or popped? And then by having these scripts and this analysis running in the background and configured to email or alert our security team or SOC or our support desk, if we configure that script to automatically tell us that there has been a change in between these instances, we've potentially caught a breach automatically without any more effort on our side here. All right, we actually went much faster than I thought we were going to go. So we have, this is just the output of one of those files, just so that I'm not making random stuff up. Yes, this Autoruns is returning as we are going. And then the next slide here is questions. A couple of things just before we do start with any questions. One thing I believe I forgot. For this example, I did want to highlight, and I forgot when I was going through, I apologize. But you'll notice that I don't have the $computers.name like I did in all of the other ones. And I did want to do this as well, because if you remember, for the computers.name, that was a folder, that was a CSV file that was specifically had the name as a field header. If you have your own list that is purely the file names, you already have the header omitted. You don't need the .name, you can just use the $computers and then prime it in the exact same way. So I did want to make sure and highlight that. And then jumping back to questions here, before we get into questions, as I said, we did have a couple of takeout boxes of some more code examples that we don't have time to do a full presentation on. So we do have a whole bunch of references. And then here's the credentials thing that I was mentioning earlier, where since this is a lab environment, just for ease of use, I have a bit more permissions that you will probably have in your own environments. So you can use these slides here to show you what you need to get your credentials working, which is built into PowerShell to make sure this is all running securely. So I'm just going to run through these slides pretty quick so that it's saved for the YouTube recording. And then if any of you want the slides to have the code on hand, you can reach out and I'll get the slide decks to you. All right. So on that note, I think we have about 5 minutes, which beat all of my practice runs. So are there any questions? And where's my mouse here? I don't know, like, you guys have to throw more puns in it on my test runs, but there aren't many more that can fit in half naturally here. Yeah, Newman, definitely. If you, like I said, I had my email on the first slide here, so you can email me and I can get that to you, or there's some kind of direct messaging thing. If you drop me your email, I'll get that sent out to you. So for Dan Hoyne, or I apologize, Dan, I probably butchered your last name there. The invoke command you're running as admin or system provisioning. So in my lab environment, I was using an admin account that has administrative rights directly to each of the workstations. And that's why I had and let me click back into PowerShell. And that's why I had I am going the wrong direction. That's why I had the credentials sections here. This walks through the steps of how you are going to access. So PowerShell is essentially built from the ground up with as much security as possible. So the only reason that the earlier commands were going without credentials is because it knew that I was running an administrative account, that I already have the remote privileges to access that device. If I'm running the PowerShell on a non-privileged account, in order to reach out to any of these remote PowerShell instances, I need to put in credentials of an account that does have the right administrative privileges on that device. And some of that setup is covered in the enabling PS remoting section, those links that I had provided. And then once again, I have the slides here of just the different ways that you can use credentials, whether you're just doing a one-off command, so using your credentials ad hoc, or if you're sitting down for a couple hours, you can save your credentials into a variable where it's saved as a secure string here, and it can so you can use your credentials without having to type it in manually for the life of that PowerShell session. All right, so I'm not seeing anything. So hopefully for you guys, that was much smoother than it felt for me as a first time here, but thank you very much for attending. And I look forward to meeting and chatting with you guys in the future.